For Q14, we have like clipping and or limiting circuits. So we have to draw the input and output waveforms on the same graphs and also plot the transfer characteristics for each case. So let's start with part A. So in this case here, we know that the input, so let me draw here the input, right? So we have time here and voltage. Let's consider 1 period and half of the period, right? So the input, it's a sinusoid, so it's just like this. And then here we have 8, here we have -8, and we have to assume that they are ideal diodes, right? So this circuit here, it only allows current to flow in this direction here, right? And that just happens when the input voltage is positive. So when the input voltage is positive, right, the diode becomes as a short circuit, and then the voltage, the output voltage that we are measuring, which is the voltage across the diode, it's going to be just a short circuit to the ground, so it's going to be 0. Now, when the current is flowing on the opposite direction, when the sinusoid is negative on the second half cycle, the diode blocks that current to flow. So this diode becomes an open circuit. And then as an open circuit, so if we open this one here, imagine this is an open circuit, right? The voltage V0, it's going to be equals to Vi. So in the second half cycle, the voltage is just the same as the input voltage. Okay, so this is Vi and this is V out. Now if we want to plot the relationship between V input and V output, so this is V input, this is V output. For positive values of Vi, the output voltage is 0. So the output voltage is 0, right? And for negative values of the voltage, the input voltage source, the output is the same value, right? Because if you look at here, it's just the same value as the input, right? So suppose we have -1 here and -1 here, let's say -3 here, -3 there, or like -8. Let's generalize for the maximum value of voltage. Then this would have like it would be just like this. Okay, so let me just -8, so -8 here. So that's the characteristic of this circuit. Let's go to the next one. So for this one here, we have like double diodes, right? So they are like on anti-parallel configuration. And in this particular case, if the voltage source, the input, is positive, right? So the potential here, it's positive. We would have a current flowing in this direction here, and then V out would be equals to 0, because it's just a short circuit, right? Now, if this potential here is negative, it was positive, on the second half cycle of the sine wave, we would have a current flowing in this direction here, right? And then V out would be also 0, because it would be a short circuit again. So if we plot, so let me just finer tip. So if we would draw the input in the time, this is time, this is voltage, this is half a cycle, this is a full cycle. It would be something like this, right? The same waveform. But then the output is always 0. Okay, so here and there, let's see, it's 15, right? So the input and the output, this is VI, this is V out, and the input output plot would be just something that for any value of input, V out is always 0. So it would be something like this. From 15 up to minus 15 volts. Okay. And for the third circuit, now we have a voltage source of 2 volts connected in series with diode 2. So if the voltage source, if the voltage at, because here we know it's 0, right? It's grounded. So if this potential here is positive, this diode is conducting, and then V out is equals to 2 volts, right? Because it's just like the voltage across these 2 volts voltage source. Now, when does this node here is positive, right? When does the voltage across diode 2 is positive? So if we say that we have a current flowing here, right? This one is just an open circuit. So we have, let me do the analysis down here. So we have minus 10, okay, times the current I times 1K minus 2 volts, and that should be equals to 0. So the current I is equals to 10, right? Or like, let's say we don't know the value of the voltage. So it's just like minus VI. So it's VI, because then we can figure out what's the condition to have like a positive current. So it's VI plus 2 volts divided by R. Now for this current to be positive, and indeed we then observe a current flow in this direction and diode 2 is conducting, this numerator here must be positive. And that happens when VI is greater than minus 2 volts. So for values of the voltage, of the input voltage that it's greater than minus 2 volts, we know that V out is equals to 2 volts, which is the value of that voltage source. Now, for conditions where diode 1 is conducting, right, and it will conduct when this VI is less than minus 2 volts. So when VI is less than minus 2 volts, because we know that if it's VI is greater than minus 2 volts, then diode 2 is conducting, right, because we have a positive current flow in that direction, and current can flow through diode 1 because it blocks in that direction. But if the voltage VI is less than minus 2 volts, then current will be allowed to flow in this direction, right, but blocked in this one here, so diode 2 will not conduct. And then V out is just the voltage across diode 1, which is a short circuit, so we are basically measuring the potential difference between two nodes that are connected to the same place, so there is no potential difference, so V out is equals to 0 volts. Now let's plot this in the time domain using the waveforms. So this is time, again, t over 2. Then we have our input here. This is 10, let's say, yeah. This is minus 10. And there's another point of interest. So let me just erase this one here and start right here. There's another point of interest that it's exactly minus 2 volts, right? So if the voltage, the input voltage, remember, it's greater than minus 2, right? Then the output voltage is always 2 volts, okay? So there's another trace we need here, 2 volts. Actually, there was my mistake. So the voltage here is on the opposite direction. So actually the voltage, it's minus 2 volts. Sorry, it's minus 2 volts here. Okay, so there is no point of interest. I just forgot that the voltage is reversed there, right? So we are measuring actually minus 2 volts. So for all these conditions, so let's say here, right, the output voltage is always minus 2. And then if the output voltage is lower than that, right, less than minus 2 volts, then the output is just 0. Okay, if we want to plot the input versus output, out, so we know that minus 2 is a point of interest, right? So if Vi is greater than that, then the output voltage is always minus 2. And this goes up to 10, right? So it stays at 2 here. But then for lower values than minus 2, it becomes 0. Right? You can just erase this one here. So that's the input-output characteristic of this circuit. So here, remember to always put your legends and your axes, label them, everything. Okay. So this is the result for this problem.